to you all. One more session, one more topic, and one more enjoyable 1.5 hours. Afterwards, more enjoyment because you'll be having lunch. Okay. Very nice of you. Thank you so much. And this is going to be on communication engineering. But as usual, my first slides will be always an introductory slide just to recap what I told last time, or it will be also a indication to some people who didn't attend fully last session. Okay, that's actually the one. So that's actually the one. We are almost here where it is last session but one, and it's going to be communication system. This is what it is actually, and I'm going to talk about communication. Communication is something which we cannot positively communicate in 1.5 hours. It's almost a month's course, okay, which I have done it in places like Siddhaganga Institute of Technology, Tumkur, and other things. It will be very interesting, actually. Okay. So that's do engineering. And last time, evolving technologies and engineering is do. Okay. That means what? There is going to be a difference between engineering and technology. All of you must know because the syllabus is the same for everything. But a person can become a technologist or can become an engineer depending upon how he orients himself to this particular topics. Okay. And this is something which I always show. Please understand, your graduates will either design or use. But basically, he should be a system man, not really a simple AND gate, OR gate, NAND gate, or microcontroller, microprocessor, or even analog modulation or digital modulation. You should know the total system in which either the analog modulation can be used or digital modulation. And once he understands the system level, he knows which one should be used. That's how it is actually basic. Please understand system, system, system. That's all it is. Okay. And this is my background. I told you once, and I'm going to just repeat that. My job is hobby, passion, whatever name you want to give it. Actually, I am transforming engineering degree holders to engineers. That's actually the first one. I am shifting the students who are coming out, or the graduates who are coming out of an institution, from teaching learning process to learning process by doing. Okay. And I've also done a lot of work with the institution to reduce the between, or we call intelligent gap between the institution and the industry. That's actually the one. I think all of you should know gig economy is already there. And today, the finance minister of the country will be unleashing the budget. We all expect, technologists are expecting, there will be a lot of things are going to be given as some sort of a gift or some sort of a concession or some sort of a focus in the budget. That's all I understand. And there's a lot of skill India has happened. And today we are actually trying to do skilling, reskilling, upskilling, that type of thing. Okay. And I am going to talk only about the knowledge, that is communication system as a knowledge. And there are better people, as I used to tell, to talk about the LabVIEW and other things. But only thing is actually, I again tell you, knowledge is paramount and skill can be adapted to what is available on that day. As I told about my own self, actually, I graduated with vacuum tubes and post-graduated with transistors, bipolar, then probably went into small scale integrated circuits like gates, etc. Then moved over to what is known as actually microcontroller, microprocessor. Then finally ended up, when I finished my sort of engineering job in Indian Space Research, I moved over to system on chip or system on module. That's actually the way. And I feel that you should basically think about becoming a system level designer, give more priority to the knowledge, and slowly update your skill as and when new tools, new platforms are occurring. Today it's NI LabVIEW, tomorrow it will be something actually. Today, I personally feel, though I have trained a lot of people in terms of skill, CLAD, CLD, CLED, etc., etc. But basically, please understand, still the product has to be designed with a very, very right type of software or right type of implementation software, which should sit on a small space. And I think the graphical system design falls short of that. Okay. Competency, again, I am referring knowledge plus skill. Skill will keep on changing depending upon the new tools which is coming up on the stage. Knowledge more or less remain the same. Actually, communication system, whether it is analog, digital and all, is all there. Today, wireless communication has come, satellite communication has been seen, and optical communication will grow as the days go by, because we are going to have optical fiber all over the country very soon. Actually, whenever we take students from the engineering institution, we only ask him, hey, you have got a degree. Like you, so many lakhs of people have got degree. What is that you know? Have you done a project? Have you thought about the project? Have you thought about why the project, what is the project, and how do you implemented it? And can you communicate clearly whatever technical things you know? And the solution should basically address the global challenges. Okay. And we are looking for students who are more than the academic sessions. Okay. With the corona, there are a lot of universities, they are offering degrees, or what we call actually they graduate student which was without going through the examination, as we call, or the evaluation, as one will positively do it. But corona will go, but the people who have graduated through the corona effect may not survive the days. They have to appear the examination, and we need people who go beyond the syllabus. And that is not easy. You have to really stop. This is another thing which everybody should know. Please understand, there are lots of opportunity today in this country. Okay, in this country. Of course, in the world, there are many more. I always say, if you study and earnest in application, you will open some of them and get a proper employment. If you are brilliant, when I say brilliant, outstanding, very intelligent, etc., you will have many more doors open. You can open many more doors. But if you are vibrant, current, and you should be able to be resonant with the technological growth today, or engineering novices, you will be in a position to open. The doors will open for you. You don't have to open. That's the beauty of this. And it is true. It is true. Okay. And this is actually the definition I had given for artist, scientist, engineer, technologist. An artist is one who have excellent creativity, but they don't have boundary. They can mix Telugu with Kannada, with English and Hindi, and then come out with a very beautiful this one. And there is no boundary. You can laugh at yourself and you can do it. Okay, that's the beauty of that. Scientist is one who provides, please understand, who provides postulate or theory for something, with some phenomena which is already in existence. Okay, they are the principles, they are theorems, they are physical laws. You know, Newton's law is the easiest thing one should remember, and it is a scientific fiction. Okay, scientific thing. Engineer is full of creativity. Okay, engineer is full of creativity. And artist is also creativity. What is the difference between engineer and artist? Artist has no boundary, but engineer has boundary or physical laws and mathematical theorems, etc. It must obey. It must obey. You cannot have a creativity and innovate a new product which doesn't obey the laws. Technologist is one beautiful thing. Okay, technologist is one somebody has created. They are all innovative people. Are very few, but technologists are dime a dozen. There are so many people. Okay, they will take the technology, they will take the engineering innovation and try to build new products, new markets, new methods, new processes, new materials, and then deploy it in the marketplace. That is practically technologist. It is up to you to decide whether you are teaching to the artist, teaching to the scientist, teaching to the engineer, and teaching to the technologist. Ultimately, you have to orient. Students, syllabus is the same. Please understand, syllabus is the same. Okay. If Bernoulli's theorem is taught, it is Bernoulli's theorem. If Maxwell's law is taught, it is Maxwell's law. Okay. So there is no difference in that. But it's a question of one fellow who uses the current tools, whether it is HFSS, whether it is AWS or something like that, and try to build out an antenna which occupies a very small, tiny space and must be broadbanded. That means you cannot have 100 antennas in a place, one for this particular spectrum, one for this particular spectrum. You should have an antenna which is broad spectrum, not easy to design. Please understand, HFSS, you go and use the HFSS for doing that, you will really know how your impedance mismatch is addressed by the tool. So ultimately, everything is experimentation. What is experimentation? Actually, most of the people, particularly in the academic institute, think that, oh, our lab has got so many experiments. No, it has got exercises. You have not created a lab where the students are doing experimentation. Students come to the I am taking microprocessor lab, which we have corrected in so many places. Microprocessor lab is there. In the microprocessor lab, the microprocessor kit is there. Okay. Usually there are about 10 exercises which are there. Addition number, what is it called? Increasing or decreasing numbers, etc. And these numbers, to be frank with you, many of the colleges, the program is written on the blackboard or the whiteboard. Students copy that, okay, and then go particular output, and that output provides it's there. Actually, you don't have to bother about that output because Intel has not designed a product which will not work. It will work. Okay, so it will work. So what is the basic thing? You have an excellent copy. The fellow, only thing what they have learned is actually how to key in a code. That's all he has learned in a microprocessor lab. See, in your microprocessor, there are at least 4 addressing modes. Have you have any particular program which uses the addressing modes, various addressing modes, and return the program and try to ask the students to find out what could be the difference, what could be the impact of the different way of addressing modes? Not done. It is not done. Actually, an execution time, no student is calculating. I'm talking in really absolute pity for the students because there's no questions asked by the model question paper and all, so they don't know. That's all it is. Okay, so learning must be done only by experimentation, not by exercises. 3 hours he has stayed in that particular lab, he has not learned anything. So we have to create active learning. Learn by doing, learn through experimentation, learn through solving exercises. And that is actually, we have a knowledge, we are applying the skills, and we are getting the competent student. Competent student is what, competent graduate is what industry requires. Not knowledge-based, not skillful, we need competent. The fellow should be able to build an application using the skill and then using the knowledge and the skill and create it. Okay, that is what is industry. There are so many industries. Every industry wants competent engineer. You go and look at in your college whether this student is a competent engineer, knowledgeful engineer, or skillful engineer. You will know the difference between all the three. Okay, these are all the industries which even today they want hundreds and thousands of students. Okay, see, for instance, today Tech Mahindra has announced that they're going to throw away 5,000 people from the ITES services. Okay, that is the services which is basically giving good salary, but they feel that we should go more to engineering and not to the software oriented or IT enabled services. They are moving. Okay, so beautiful applications. And all the applications, you take the latest announcement by Tesla. They're going to have a standard, motor making, car making, automobile, electrical automobile making company in India. That means most of the people are looking for our engineers to help them to build a product better, okay, for the global consumption. So your student must be good. Your graduates must be good, okay. So this is actually, I always show this again to people because of the simple reason, unless and otherwise the person understands the systems approach, solution engineering, and he will not be able to solve today's problem. Every problem, every challenge today thrown is multidisciplinary. And just by knowing operational amplifier or microprocessor based system or C or D programming will not help you to find a good job. Do you know how to mix and match the hardware and software and provide what we call actually a very, very optimum solution for a user? Okay, optimum solution for a user. And he has a lot of challenges, so he will be able to do that. Okay, this is actually my. Now I'll come to the today's topic, which is communication systems engineering. Actually, there is one. I used to do what is known as actually entry-level students. You call interview, you call Viva OC, you call anything. These are all mock Viva OC, which used to be conducted in most of the colleges. I have done it in 10 institutions, all good institutions like Amrita, VIT, like that. Okay, private university. I don't want to call them deemed because they are much better than the established university. It's called private university. Okay, and my problem is if I ask them actually out of the science subjects what you have learned, which one you don't like, they will immediately say physics. There are people who like mathematics. There are many people who like chemistry. There are people who like biology or anything. But physics is very, very handful of people only like physics. Similarly, I'm giving this as a input for you. Dr. Rohit is there. You have an excellent electronics and communication department with many things. You are, I think, admitting 120 students or 180 students per semester, per year. And it's going to be a great thing. Okay. So you ask the students at the 4th, 6th semester, either you like electronics in the electronics and communication or communication in the electronics and communication department, you will be surprised. 90% of the students like electronics, not communication. Very sad. Very sad. And communication is an absolute essential. Fortunately, I heard the Mr. Sunil's last lecture actually, and one faculty was asking actually, sir, we have a 20-kilometer distance. How do the IoT works? Okay, how do I make the IoT to do it? So there are different standards available. LoRa, you have actually Wi-Fi, you have IP-based S6 low pan, you have various types of things, and you have to mix and match, which is good. So if you ask the same question to me, if the faculty is there, he will understand. See, for instance, what you can do is actually get a small, what we call multi-protocol wireless gateway made, okay, using, so that particular information available, that will take a Bluetooth or Zigbee or Wi-Fi or NFC or any one of those standards input, and then that will convert into GSM or IP and send it across to long distance. If you try to send Bluetooth to long distance, then you are innovating something. It's not possible. Okay. If you are going to get adapted to this LoRa is very good for long ranging. It's called long ranging. Okay. Long ranging LAN or WAN, whatever it is. Long ranging. But LoRa is new to you, all of you. LoRa is not taught in any places, and it is one of the best thing, but we don't know. Only French people know. Okay, so it's not. There's no point in trying to rediscover the whole thing. So move to IP, which you know very well, or to GSM, which you know very well. That's actually how the communication engineering. Please understand, communication is a bountiful of technologies, and you will have this particular thing. I always show this particular slide because I created this. Okay, here I am only interested in looking at this. Okay, at this. So the software which has to be provided on the application layer is acquire, analyze, present, display, communicate, and control. To communication. On the first day, we talked about automation. More or less, we talked about all the other things. Please understand, when you teach microprocessor, microcontroller, various micro things, actually, you try to concentrate on this and then divide or partition the functional blocks into these four. You will be able to impact the class much better. I can tell you that much. Okay, because I'm teaching this. Okay, I'm teaching this. Communication systems engineering. That means communication is, of course, everybody will say, so communication is a very easy thing. Yeah, it is a very easy thing. Okay. System, again, engineering is creativity. Look at it. System is, you should look at it as a system because there is an antenna. Which antenna is basically a mechanical fabrication. Okay. The surface accuracy of a, say for instance, antenna is lambda by 32 or something like that. So that is the only microwave thing which is available. All the other fabrication, etc., is basically mechanical, but we call electronics. In mechanical engineering syllabus, there is no antenna, but in electronic syllabus, antenna is very big thing. Okay, engineering is basically creativity, which should bound the laws. Maxwell law you should know. Otherwise, you cannot build an antenna system. Communication. We are going to dwell very beautifully this communication. Many things which you have casually assumed in teaching or in learning now will make more meaning to you. Please understand, communication system engineering is basically a 1 month course of 8 hours every day with me. Okay, I'm going to try to focus on some of the critical things which you should know if you want to teach or learn communication system engineering. That's all. In 1.5 hours, 90 minutes, with all my blah blah, everything, etc., probably I can only do those things. Okay, and I'm trying to do that. See, when I go and look at actually a communication syllabus of communication engineering syllabus of a typical university or an institution, they always say review of probability. So there will be mathematics, probability and statistics, one of the mathematics thing. Signal and spectra. You try to learn in signals and systems, you try to learn this in DSP. But when you come to communication engineering, you forget. That means when I tell a person what is sin x by x and how it is applied in a communication thing, they don't know. They don't know very well. Formatting and baseband modulation is basically starting actually. So in this particular thing, you ask anybody modulation, that fellow will hound himself because he doesn't know how to define modulation. I'm going to define, okay? Baseband. So you have a baseband, you have a band pass, you have, of course, RF. I didn't mean RF here because I don't want to teach that also, okay? The baseband modulation, see, for instance, you take a QPSK or a PSK or a QAM. How do you define modulation? So if you go and ask your students, whenever you ask what is modulation, define modulation. Modulation, according to me, I have a signal, and that signal will be You will use modulated. I don't use modulation. I say it should be mixed with an RF carrier and transmitted, and the transmitted signal will be received by the receiver, etc. This is very good for a carrier modulation. It is not good for baseband modulation. In baseband modulation, we don't have a carrier at all. We don't have that type of carrier, what he means. That is high frequency sinusoidal signal. He doesn't, we don't have it. So how do you define modulation? So those people who are teaching wireless communication, and if you happen to have Rappaport book, read the 6th chapter, first few lines, you will know modulation very beautifully. There is no need for you to ask Jayaraman what is modulation. You read and try to impart that to your students. Modulation. I just this 12 o'clock, 12 gongs will go, and I have to pass during that direction. Okay. So this is actually meant for people. When I ask some people who are all participating, mostly electronics and communication, but some people can be other disciplines also. This is the statement I get. So this is prepared, okay, prepared for me. So communication is the activity associated with transferring, distributing, exchanging information. Okay. So now you go to the next one. So you ask the student, what is information? What is signal? What is data? What are you communicating? Are you communicating the information? Are you transferring the information? Are you transferring the data, or are you transferring the signal? You will know how much of communication he knows. Okay. Of course, there is one more thing. Is actually it is one-to-one, actually, or one-to-one. I talk to you, and that's all. You cannot talk to me. Another one is actually one-to-many. I broadcast now as I am doing, and everybody is broadcast. Everybody is listening. This two-way is actually two people can talk. What we call alternate. That means I talk, you listen. You talk, I listen. That is actually one. Or all the people will talk in all the time. That is also there. Okay, that's actually the one. And data, text, graphics, voice, music, video is what. Why we are telling this? Why I showed this? Please understand the requirement of a communication system for data, for transferring data, will be totally different from data transferring text. For transferring graphics, the fellow should know, hey, I have to transfer graphics. How do I build a communication system? What is the type of modulation I should use? What is the type of bandwidth I should look at? What is the spectrum I should use? All these things. That is why I'm showing. See, there are two things. One is actually just an image. Another one is a video. That is moving image is called video. Okay. So whenever we talk these two, the requirement of the communication system is different. So the teacher should basically move the students from understanding what is an image, etc., the characteristic of the image and the characteristics of the communication system that is required to move that image across point to point, from point to another point, okay, or point to multi-point, whatever name they are happening, okay. This is actually what we are looking for in every student of yours. So I have analog signal, I have digital. See, the signal is actually, whenever I ask a student, I'm all reflecting the answers I get in my interviews, okay. Analog signal, he will tell so many things actually. Analog signal is what? Analog in time, analog in analog in amplitude. That's all it is. Continuous in amplitude, continuous in time. That's analog. Okay. That's all you should say. You should not say that it's a signal varying actually, all those things. No. That's not what we are looking for. And what is digital? Discrete in time, discrete in value. That's all. Now we have there is one more concept which is called sample data, sample signal, you know. The sample signal is what? Discrete in time and analog or variable or continuous in amplitude. This is all he has to say. A person should be able to crisply present the definition very well. No interview ask any super duper question like how the Gaganyaan mission is going to be operational. Nobody is going to ask that. That and all we will teach. But if they doesn't know the fundamentals, we don't know how to teach anything. So the fundamental you impress upon. Of course, you will say, sir, many in the industries come there. They say that actually our syllabus should be changed. The syllabus need not be changed. Syllabus has to be taught in a way which meets the user's expectation. Okay. So I'm going to talk about simple diagram. This is a transmitter. This is a channel. Or now, see, for instance, whenever I talk to the student, what is the difference between a path? What is the difference between a path, a medium, and channel? Channel is not path. Path is not channel. It is, we are using it as though interchangeably we are using. Channel is different, path is different. On a path, we can have multiple channel. That's multiplexing. Okay. On a channel, we will have only one signal riding at the time. Okay. So if you are going to talk about, say, for instance, E1, T1 carrier, etc., that actually talks about 24 channel or 32 channel, but it doesn't talk. Only one medium, but 24 or 32 channels. Okay. So channel should be understood. Okay. Receiver, these are all digital communication. Whenever I talk, actually, I talk digital communication system and analog communication. If somebody wants it, actually, I can talk also, but I have now more or less stopped it because nobody wants it. Now, medium. So that is why I have put this question mark, because channel is not medium. This is written in a textbook, so I have put it as it is. Please understand, channel is not medium. The student coming out of the Your Institute must know the difference between a channel and a medium. If he doesn't know, he is going to be in trouble. Okay, at least with me. Okay, probably he will not see me. Okay, in wireless, radio, microwave, satellite, cellular, wireless LAN. Today, everything is wireless. Whenever you talk about an IoT, if there is no wireless communication, there is no IoT. Okay, and there are a lot of standards. Okay, so wireless communication, the person. It doesn't mean that wireline communication is gone. Today, if you really see, there are so many smart cities are being, and roads are being dug left and right, and they're all trying to lay fiber optics all over. That means you are going to have a huge bandwidth and huge data rate available. Okay, and satellite transponders, all those things. Okay, so understand it. Actually, you have medium. Now, what is the next one? This is taken from, this particular diagram is taken from Digital Communication by Bernard Sklar book. Okay, and actually, whenever I used to teach digital communication, that is my reference book. Simon Aikens' second book. First book is Bernard Sklar. Okay, so look at it. I have the thing, I am converting into digital. Source encoding, encryption, authentication. Okay, channel encoder, multiplexing, pulse modulation. See, you have modulation also. There are three types: analog modulation, pulse modulation, digital modulation. All the three are different. So modulation is a generic name. Modulation has a definition, which we are going to talk. And pulse modulation is different. Analog modulation is different. And in analog modulation, you have a baseband modulation, you have a carrier modulation. Okay. And band pass modulation, you have another thing, spectrum modulation. See, look at it, spectrum modulation. So if you really look at the communication system, there are only two things. One is modulation, second one is coding, nothing else. That means modulation, coding, whole thing is communication. That's all. You have various types of coding techniques, you have various types of modulation techniques, which you are going to see. Okay, modulation technique. Many electronics and communication professors or teachers or faculty who have years of service will think, why this fellow is telling us all fundamental things? I believe in fundamental. If fundamental is clear, I can build the empire on it. That is what my college has taught us. Okay, my Birla Institute of Technology It's not great. Every faculty is as good as Birla Institute of Technology and Science faculty. We are taught fundamental. Why? Because we have to grow on the fundamentals further. So we are taught. Okay. This is waveform channel. Channel is there. So you have a transmitter, you have a receiver, and you have this. Now, the person is supposed to be knowing all these things. Okay. There are some optional. I have put optional and essential, and that is only for the people who want to more about it. So, how many types are there? Look at it. Character coding, sampling, quantization, pulse code modulation. Look at it. So this is modulation. In pulse code modulation, what is the carrier used? If your student is going to tell me carrier, I'm going to ask him pulse code modulation. Okay. Look at it. Source coding, predictive coding, block coding, variable length coding, synthesis analysis coding, lossless compression, lossy compression. I did one research, that is PhD. I'm not a PhD person. There is one graduate, postgraduate who got research guide actually, who is very closely known to me, and he knows that I know a little bit more than him in communication. So he sent that person, but it was a lady, and he sent that person to me and say, can you guide her and try to bring this what is called we have one survey paper, first paper, survey paper. Okay, can you get this done? Okay, I said yes, I'll do it. So she was doing convolution coding and probably an A to D converter, which is basically a different type of A to D converter. Okay, A to D converter. I did the project for her. Up to 2 years we were working together. Okay, and of course she won't ever come to me because she was really harassed. I was asking so many questions, but she has to study a lot. She had a family, she had kids and all those things, but we worked very closely and she got a PhD. Okay, very good. And baseband signaling, look at it. Now this is another word I have brought it, signaling. That is, modulation is one thing, signaling is another thing. Okay. Now equalization. Every medium has got certain problems or what we call limitations. And if in order to overcome limitation, we do something at the transmitter end and undo that in the receiver end, and that is ensure that the data goes to the transmitter, on the line to the receiver without major problem. Okay, so band pass signal, channel coding, multiplexing, multiple synchronization, spreading, and encryption. Look at it. Is there anything other than modulation coding in this particular blocks? This is what is communication system. Okay. Channel encoder, this is another thing. I always do too many this one because I want everybody to understand this actually. Okay. Look at it. Source encoding, decoding. Okay. Format. Channel encode, decode. In source encoding, I am removing redundancy. In channel encoding, I'm adding redundancy. Okay. So if you really do that, actually, that means what? In a typical path or a medium or through the channel, your data is likely to get affected and 0 can become 1 or 1 can become 0. So in order to retrieve that particular information at the receiver, I add redundancy. Look at it. In source encoding, what I do? I don't want anything to be duplicated. So what I do, whenever possible, if there is a redundancy telling the same thing, I remove that redundancy. So here, I am trying to reduce the number of bits to represent one signal. Here, I am reducing the error due to the signal, bit gets modified during its transmission through the medium. I am doing that. Okay. See, modulation. Generate signal waveform which is suitable for transmission over the channel. How many modulation, demodulation? We are going to talk about it. It's a beautiful digital communication. This is the essential part of it. What is that? Timing and synchronization. And the timing is a very important thing in a digital communication. Otherwise, your whole thing, that means your clock, I'm talking about the analog signal or digital signal generation, your clock has to have a beautiful coherence. Otherwise, your signal will never be recovered at the receiver. Okay. This is actually for myself. Okay. So now I wanted to go further. In a digital communication, if you want to build a digital communication, or if you want to build the students in the digital communication, then what is the thing? First, reliability. Reliability is what? To get the probability of error, bit error rate, as they call. Reliability. How reliability is defined, it's a beautiful thing. Reliability is the probability that the system, service, product function as per the design specification at the rated condition whenever it is called to perform. If you really look at the cyclic redundancy code is there, convolution coding is there, and you have block coding is there. You have various types of coding. Turbo coding has come. So you have various types of coding is there. And each code adds certain extra symbols to ensure that it can be recovered at the receiver. Okay. I am sure all of you would have studied Viterbi coding. Okay. And Viterbi coding is an excellent method by which you can probably this is 0, probably this is 1. Okay. That's how we predict. Efficiency. This is another thing. What is efficiency? If you ask anybody, efficiency is output upon input. Oh gosh. Output upon input. How do you apply it to digital communication system? Look at it. To efficiently use the resources such as frequency, bandwidth, and transmission signal, there are two parameters. One is bandwidth efficiency, one is power efficiency. Okay. And we have to ensure that bandwidth efficiency is what? That is, in a PSK, assume that I have a 50% bandwidth efficiency. And in QPSK, I have 75. In QAM, I have 80. Like that, you can keep on increasing the efficiency. Bandwidth utilization efficiency. Bandwidth efficiency is not bandwidth efficiency. It is bandwidth utilization efficiency. So, if I have a small bandwidth of few cycles, if I can send one signal and it can represent 2 bits at the same time, I have effectively used the bandwidth available to me. No, that's how it is actually. Okay, simplicity. No confusion will be there, particularly in the receiving system. No confusion. All of you would have studied super heterodyne receiver, and simple should be simple. Okay, that's actually the one. And usually the receiver is designed simply because it's going to be made in huge numbers. Transmitter can be one, I can fine craft it, but receiver has to be very fine tuned. So these are all the things. Signal to noise ratio. In an analog communication, signal to noise ratio is the sacrosanct thing. That means anything anybody will say signal to noise ratio. Okay. Carrier to noise ratio is used in satellite communication very well, and you can say bitter rate for the digital communication. And bitter rate is proportional or somewhere related to signal to noise ratio, but we don't say signal to noise ratio. We talk only bitter rate. Okay. Channel capacity theorem. Majority of the people have forgotten channel capacity theorem. I will tell you. Channel capacity is equal to bandwidth into 1 plus log, 1 plus log of S by N plus 1. That's actually the one. Okay. And this is one channel capacity theorem. The same Simon Haykin's book, if you really read it actually, that fellow will say channel capacity is also defined another way. 2b into log of levels. Okay. So in PSK, you have one channel capacity. In QPSK, you have another channel capacity. So please understand, channel capacity theorem 1 plus log of S by N, bandwidth into log of 1 plus S by N to the base 2. That is one thing. That decides what is the maximum channel you can send through, what is the maximum data rate you can send through this particular medium. Okay, that's gone. Now, I give it to my engineer. That fellow is supposed to try. Can I use PSK? Can I use QAM? Can I use OPO PSK? Or can I use some orthogonal, what we call frequency division multiplexing? How do I utilize the bandwidth fully? Because one of the criteria for the choice is actually is bandwidth utilization efficiency. So I have to do that. Okay, this is actually the beauty of it. Channel capacity theorem, no electronics and communication student or the faculty should forget, and they should know how to apply that. Okay, this is all various definitions. Okay, now look at it. 4 main concerns of a communication system. One is the waveform. Yeah, I'm sure all of you will know that actually I put a cosine waveform and then try to say optimize that particular thing, etc. Bandwidth and power. Third one is the noise. Fourth one is the cost. Now look at it. Noise. Noise is a very beautiful word. What is noise? All in the audience will say that a noise is unwanted signal. Very simple. Noise is simple. Now, if you really look at some of the data sheet of a analog to digital converter, that fellow will say noise plus distortion. Because most of the faculty and students think that distortion is also a noise. No, noise is unwanted signal. What is distortion? Distortion is unwanted frequencies in the wanted signal. That comes actually a linearity. Okay, unwanted frequencies in the wanted signal is distortion. Noise plus distortion is what we have to be concerned with. That's all it is. Okay, analog digital is okay. I'll keep on doing this this one actually because I want at least some students to give at least this particular block diagrams in the interview. They don't give, sir. I'm sad to say that because they don't like communication. That's the basic problem. Advantages, disadvantages, I'm sure many of the people would have taught, probably they know more about this than me. Okay, Fourier transform is one thing. What is the basic thing? Now, bandwidth I told, but I have only a signal, you know. Suppose I have vibration. Vibration is a signal, that is time domain signal. So what is the basic thing? I should know what is the bandwidth of the medium I require for transmitting this. How do I get the medium bandwidth? I have to convert that into frequency domain, find out the maximum frequency content and say, this is the bandwidth I require. So Fourier transform. Now you go, without knowing this, if I go to LabVIEW, I will go mad. In the LabVIEW, if you really look at it, we have signal processing, fast Fourier transform, etc. So many icons will be there. You have to choose one. You should know which one to choose. For that, you should know the knowledge. Please understand, LabVIEW is one of the most simplest tool to use. But if you don't know knowledge, you go mad. Knowledge is required. The knowledge comes out of these particular textbooks of various domains. Okay. Fading channel. All of you would have seen this fading channel. We have short-term fading, long-term fading. All those things are there. Okay. Bandwidth of the signal. There are so many bandwidth. Half power bandwidth, noise equivalent bandwidth, null to null bandwidth, fractional power, bounded power, absolute power, the absolute bandwidth. So many things are there. See, bandwidth is, suppose I ask him what is the bandwidth, that fellow will say something. No, I want actually noise equivalent bandwidth. That fellow will suffer. He doesn't know. Okay. Additive noise channel, I have put it. Actually, you would have taught. Actually, an average communication person must know more about noise than about signal. That's the problem. Okay. And noise can be from anywhere. Okay. Okay, now I'll go into the engineering because of the simple reason we had. See, when I studied one textbook on engineering, I think I studied one of the telecommunication made simple or some book actually. This is what it is. What is the information sources? What are the broadcast? See, I'm talking about communication. I would have studied at least about 9 to 10 books almost fully. Okay, except probably detailed equation, wave equations, etc. I would have not studied, but I know all the books more or less. Okay, media based. This is what it is. See, all of you would have known. Okay, that I will talk later. Review of probability. That is the first 2 chapters. Path and channel characteristic. This is what you should understand. If you want to transmit your signal over a medium, it is wired or wireless, you should know the characteristics. What is relay fading? What is called normal distribution of this one? What is actually how the noise profile is there? How do you reduce the noise? How do you reduce the internal noise and external noise? It's a very big thing, I say. See, for instance, simple thing in your op-amp, I'm talking about the analog circuit, op-amp, you have a single-ended mode and differential mode. If you use a differential mode, automatically noise gets suppressed there. Suppressed, not removed, suppressed. If you use a single-ended, noise will get added. Okay, so if you talk about an instrumentation amplifier, I will use the op-amp in a differential mode only, and I will not use it in the single-ended mode. Okay, signals and spectra. The signals and spectra, best tool what you can learn is from LabVIEW. It's a fully signals and spectra, you can create a signal, do some changes, and see the spectrum of that. More or less within 10 minutes, you can complete everything. And that is the beauty of it. Baseband modulation, baseband demodulation, source and line coding. See, look at it. Everywhere coding is there. Modulation and demodulation, band pass, multiple access, synchronization, source coding. This modulation and coding is the basic thing. I'm going to take one minute and then come back to you. See, I am living alone. So whether it is a gas, whether it is power, everything I will take care. I don't know how I'm going to take care, but anyhow, don't mind it actually. Okay, modulation encoding, as I told you on that day, that it is the only thing which is going to make this communication system. Okay, communication engineering is only modulation and coding, nothing else. Okay, and if you really take similarly, if you want actually a DSP, what is DSP basically? DSP is very simple. Time domain to frequency domain to time domain transformation. Analog signal, sampling and reconstruction. Okay, these are all the three. And third one is filters. IIR filters, FIR filters, every filters you can think of. So if you really say, Jeraman, I want to learn about DSP or anything like that, you really have to know only those things, nothing else. I'm going to take some 2 minutes, that's all. Gas, if I miss, I have to go and pick it up. I'm a 75-year-old fellow, I cannot pick it up. Okay, so I want to do that actually and close it. Dr. Rohit and colleagues, please excuse me for such a thing. It's a gas break. Okay, Just as we have a biological break, you say that is a teacher's gas break. Okay, that's all it is. Okay, but nowadays,
It's okay, sir. It's okay. Not an issue. Not an issue, sir.
okay, sorry, actually, because I am alone at home. My wife is not there. Okay, and what I'm trying to say is actually modulation and coding. Nowadays, we have coded modulation. We have coded modulation. Orthogonal division multiplexing modulation is there. You know, that's a coded modulation. So now a person who is teaching modulation separately and coding separately, no more it will be working. You have to. Sorry. Sorry. ಹಣ ಕೊಟ್ಟು ನಿಮಗೆ ಅದು ಬೇಡ ಅಂತ ಬನ್ನಿ 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 ಸಾರ್ ಬನ್ನಿ ಬಾ ಬನ್ನಿ ಬಿಲ್ಲಿದು ತಗೊಳ್ಳಿ ಬಾ ಇಲ್ಲಿಗೆ ತಗೊಳ್ಳಿ So, sorry, OFDM, everything is actually modulation and coding should be taught separately. Coding does something, modulation does something. When it combines, it's going to be a great opportunity for students to learn things. Okay, modulation. Now, I'm going to talk about modulation because I have taken everything from Rappaport book and it is a good book. Why modulate? How many types? Okay, modem. Now you see, look at the modem. Line modem, cable modem, wireless modem, satellite modem, XDSL modem, and like that it is. Okay, so that means what? These are all medium, and modem is associated with that. That means what? When you go from modem, from line to cable, the modem has to be changed. When you go from XDSL modem, see, for instance, today I have got a line modem. Now I am asking BSNL or some supplier to go for the ADSL or VDSL, etc. And that fellow will change the modem also. That means modem and the line, it's supposed to be there. That means what? Modem does something for that particular medium. First thing. Okay. What is that? What is that it can do? That is, a medium has got aberrations or limitations or some it will not work in some places. Okay, medium has got a lot of characteristics. That's why you are studying more about medium in the first two sessions of the institution. Okay, so the modem has to correct it. So modulation does something so that when you transmit the signal and at the receiver, demodulation is going to reconstruct it. Now I'll tell you one thing. See, a line. What is a line? Telephone twisted copper pair of wire. This is supposed to carry only audio signal. Okay. Now we are using it for your typical data rate or bit rate or bit signals. Okay, bit signals. That means what? A pulse signals. Okay. And now the modem is going to do something. A line has got only 4 kilohertz. I have a bit. Now you go back to signals and system. You have a 1 microsecond signal, try to resolve it in the frequency domain. You see what is the maximum frequency required. It will never be less than 1 megahertz or 2 megahertz or something like that. How do you send 1 megahertz signal through this particular 4 kilohertz signal? You cannot do it. That means what? You do modulation at the transmitter, convert that particular signal into an analog signal which is less than 4 kilohertz, transmitting. At the receiver, that analog signal which will come, convert that into digital and send it, processing, send it. This is what is happening. That means what? Now I'll go back to my channel capacity theorem. C is equal to B into log of 1 plus S by M. That's actually the capacity theorem. Okay. These people will use the signal to noise ratio. That noise is actually bandwidth into power signal noise density, like that and all they will say, because En squared noise is equal to 4 kTRB. Okay, that is bandwidth is going to be everything. Suppose you reduce the bandwidth, you will have less noise. That's what we have been taught. Okay, so now whenever you talk about these type of things, the student must understand at that particular time when you are teaching. That means modem should not be talked dumbly, saying that this is a modem, it will do modulation, it will do receiver. In a modulation technique, we have actually AM, FM, PM, and in the modulation, digital analog pulse modulation technique, we have PAM, PPM, PWM. In a digital modulation technique, we have PSM, PSK, QPSK, FSK, ASK, OPSK, like that, etc. And in source coding techniques, we have PCM and delta modulation and adaptive delta modulation. That means what? Modulation means something else. Why modulation? That is what we are going to look at it. Multi-level modulation. See, look at it actually. Multi-level modulation. That is, you are talking about QPSK, those type of things. Why code? How many types? Okay. Multiplexing is also another thing. What is multiplexing? Why multiplexing is used? Now look at it. When I have a bandwidth of the medium larger than the channel capacity, okay, sorry, larger, that means channel capacity of that medium is large. Okay. Now I don't have signal to use that particular bandwidth. My requirement is bandwidth utilization efficiency. Okay, bandwidth utilization efficiency. So if I have to utilize, I have to multiplex it and I have to demultiplex it. That means what? When I have one pipe, in that pipe I connect to 24 channels. That is why E1 T1 is taught. E1 T1 carrier is taught. Please understand, our whole, all of you are teaching how you are teaching. I don't want to complain. I don't want to say anything. You have to start with the medium, then slowly build one by one all the elements that constitute a transmission end. Because of the simple reason, because of the aberrations in the medium, we are creating more and more and more blocks in the transmitter and corresponding block in the receiver. That's how it is actually. So beautiful. I tell you, communication, once you study with a lot of interest, particularly if you read from Simon Aikins, Bernard Clark, Carl, or any other. I also read one book called P.C. Gupta by telecommunications. I think it is networking and telecommunication systems, I think. Okay, that's also there. So all these books are going to make your life much more better. Coding, multiplexing, and multiple access. Multiple access. So you have TDMA and you have spectrum element. That means what? I spread the spectrum and send it through the medium. In the medium, it will look like a noise, but at the receiver, I can extract the original signal by autocorrelation of the received signal with the signal that actually I did at the transmitter end. Same signal, I can recover the signal, which we call autocorrelation. So it's a beautiful way. I'm telling you that also you have spectrum multiplexer, frequency hopping multiple access. We have a slow frequency hopping multiple access. We have a fast frequency multiple access. CDMA is code division multiple access. So you have so many values. See, today, if you are going to talk about a physical layer, and all the things are being done only at the physical layer for a wireless communication. And that is what I am going to be insisting on. So modulation type, these are all the modulation type. This is only something I am talking. Down below, I'm going to show you almost 2 slides full of modulation technique. Gaussian mean shift keying is what is used in your cell phone. Okay. Look at it. Analog modulation. I have done the same thing as I told you. This is AM, FM, PM. This is pulse analog modulation. This is digital modulation. This is source coding modulation. This is actually the beauty of this. And I tell you, it's fun. Okay. Now we will talk about what is modulation. Now is definition. Go to Rappaport, chapter 6, first page. First page you will have. Modulation is a process of encoding information, okay, from a message source in a manner suitable for transmission. That's all. No carrier modulation, no one wave riding over the other wave, reaching the destination after being reflected by some sort of a layer up in the layer, ionosphere, stratosphere, electron, and then coming back and you recover that particular signal. That's all carrier modulation. No, don't bring that modulation. Modulation is a process of encoding. Actually, I forgot to add this, information carrying signal. Actually, information carrying signal. We are modulating the signal. Okay, information carrying signal from a message source in a manner suitable for transmission. Ante. That's all. Okay. Demodulation is the process of extracting the baseband message signal so that it may be processed and interpreted by the intended receiver. Now, why modulate? Given the hostile fading and multipath condition in the mobile wireless radio channel. This is, I have told about the wireless communication. Even in the wired communication also you will have this problem, but anyhow, designing a modulation technique that is resistant to mobile channel impairment is a challenging task. And goal of modulation, to transport the message signal through a channel with the best possible quality while occupying the least amount of radio spectrum with minimum power. We said in down the line, what are the characteristics? One is I should use minimum bandwidth, I should consume less power, I should ensure the noise is less, all those things. So that is all the goal of modulation. Okay. Now look at the modulation technique available. These are all the modulation technique which is used. Somebody is using it. Fortunately, I don't know much about it, but this is there. So this is modulation variety. Okay. Modulation. Okay. Coding, source coding, cryptography, encoding, error control, forward error correction, reverse error correction. Okay. Decoding. And that is what makes this particular coding important. Now I'll go to the beautiful thing called software defined radio. Actually, today, if you really look at the first day, I must, or the first phase, actually, I told software-based instrumentation. That is actually virtual. People used to talk about virtual instrumentation. I don't talk. There is no virtual. It is real. Software-defined instrument is real. And that instrument where the functionalities are implemented in software rather than the hardware. Okay, so you will get an oscilloscope, you will get a multimeter, that's a software based instrument. Okay, now software based radio. What is radio? Radio is RF system. If you really look at a radio, what is radio? A flexible hardware. In this particular thing, you have what is known as actually this is actually RF hardware, and you have a very funny antenna there, smart antenna we have written. Okay, so part of the ADC DAC also goes. Now look at this. This is all software. Now software can be used for characterizing this particular hardware, this radio parameters. I call that a software defined radio. Okay, software defined radio. A radio in which RF operating parameters, including but not limited to frequency range, modulation type, output power, can be set or altered by software and or the techniques by which this is achieved. Okay, now you go back to the question on IoT. IoT has got Zigbee, IoT has got Bluetooth, IoT has got this one actually. If I can have a software-defined instrumentation or software-defined radio, I don't have to bother about all those standards. I implement it in software. If it is GC, if it is Zigbee, it will convert, it will reconfigure itself for Zigbee. If it is Bluetooth, it will deconfigure. So I have only one particular thing, which is software-defined radio. I don't have any other standards. All standards are implemented by the software in this particular implementation. Okay, so this is what it is basically. I have basically what is known as actually a hardware defined radio, a software controlled radio, software defined radio, intelligent or in radio, and ultimate software radio, and that is all it is. So this is something keyboard display, this is antenna, all these things are being done by this. That's all. Okay. Hardware defined radio, software controlled radio, and software defined, capable of covering substantial frequency range, etc., etc. I don't want to read all these things. Software defined radio, basically understand, I have a radio whose parameters can be configured by software. That is, baseband is completely implemented in software. Okay. Why? Actually, there is one more thing which you have to teach the students is actually, what is the difference between implementing in software and what is the difference between implementing certain functionality in software, certain functionality in hardware. If you had seen my original systems approach to solutions engineering, you will know the functionalities are defined. Only thing usually, what is the target I'm going to use, whether it is going to be software, C, Python, whatever it is, or is it going to be 8085, 8086, or whatever, ARM 7, ARM 9, or whatever is the processor they are talking about. What is that actually? It depends upon the capability of the implementer and the configurability that he is looking for. If he is going to look for a lot of configurability, then software definition. If it is going to be, at least part of it can be fixed, sir, remaining can be configured. It is actually partly in hardware, partly in software. Okay. Ideal software radio and ultimate software radio, it's all will come. I mean, I may not see it, but probably some of the faculty were sitting there. So this is our original receiver. All of you would have seen this super heterodyne receiver, and this is what is the basic thing. Now slowly, this is the baseband I'm implementing with the DSP or anything like that. IF is really a hardware, and RF is positively a hardware. Okay. Now what is happening actually is the IF is being defined by the ADC, DAC, and you have this particular thing. That means my ADC sampling rate is growing high. 1 giga samples I can do. If the sampling rate goes higher, then I can even throw it in the RF system. That means what? I don't have IF at all. That means what? I do not have super heterodyne receiver. I have a direct conversion receiver. And direct conversion receiver, mixer noise is avoided, local oscillator noise is avoided, and that is one of the best receiver you can think of. Straight away you go to the DSP where you get the baseband. Okay. And beautiful things are all going in a big way. Learn. These are all, a lot of books are there. This is another way. This is the way in which I want you to look at it. I have a band pass filter, low noise amplifier, mixers, etc. This is super heterodyne DCB, AGC, ADC, bias and phase distortion removal, channelizer, adaptive filter, Hilbert transform. Oh gosh, look at it. All these things can be implemented in software. All these things can be implemented in software. I can do wonderful things. This is actually the transmitter, and that is actually the software receiver. Ease of design, first one. Ease of manufacture, beautiful. Multi-mode operation. I can have one cell phone which will have both CDMA and GSM in the same cell phone. Okay, multi-mode. Advanced digital signal processing is a must. That means what? There are many people who have done image processing, signal processing, etc. They should tune themselves to the signal processing for communication. Okay, then that will be good. For fewer discrete component, because everything is converted into software, flexibility to add any functionality. Whenever you have a software, look at your own cell phone, I say, since everything is implemented in software on an operating system, you have any, on the minute, actually, I can change various functionality without any difficulty. Flexible, reconfigurable, reduced obsolescence, because anytime the hardware can be thrown, the safe software can run. Ubiquitous connectivity, yes, brings analog and digital world together. Okay, so the technologies which are there, antennas is a big technology. I'm talking about This particular slide is meant for the people who want to do software-defined radio and they want to use one particular area and then try to become great. That means his PhD topic. Okay, so you can do this. This is what I do. This is actually sigma delta converter I used in this particular thing. And there actually we were mainly concerned with how to take care of the effective number of bits. Okay, 10-bit A to D converter I take it, but actually when I put it in the circuit, it's only 8-bit or 7-bit. So how do I improve that? Actually, I decided that actually. Hope it was there. Digital signal processing is always growing. Amplifiers, battery, recognition, behavior, design tools. Okay. Antennas, I have written more about that actually. And today, actually, digital signal processing is done by using FPGA. That means you should know VHDL. Okay, now go back to LabVIEW. See, I am telling you, you have to learn you have to learn VHDL or Verilog HDL. You don't have to. If you know LabVIEW and your target is a FPGA-based board, like any of the boards which are available with National Instrument, you just code it and download it. It is a responsibility of the LabVIEW to take care of the conversion to what we call to VHDL and target it on the FPGA without yourself knowing the VHDL at all. That's the beauty of this. Okay, and it will happen. Okay, batteries, more and more battery technology is moving, and of course cognitive science. This cognitive science, I just wanted to show one slide. I'm almost the end of it. Cognitive radio system is a radio system where the following capabilities. One, to obtain the knowledge of the radio's operational environment and establish policies and to monitor usage pattern and users' need. Dynamically and autonomously adjust its operational parameters and protocols according to this knowledge, above knowledge, in order to perform predefined objectives. More effective utilization of the spectrum. Please understand, one of the basic concept is spectrum utilization efficiency. Okay, to learn from the results of its action and then do. Now I want to talk a little bit about that. See, for instance, I have developed software-defined communication system, software-defined radio. Okay, no problem. Okay, I have defined most of my baseband parameters in. I have implemented most of the baseband functionality in software and have defined the operational parameters of the radio. Done. Okay. Now we are always short of spectrum. Okay. Actually, Sunil in his address, he told that actually we are waiting for 5G to make this particular what is it called, to make this Internet of Things to be much more accessible to many people. It's correct actually. 5G is going to do that actually. Okay. And so what is our problem? See, every spectrum has got a bona fide user. Everybody has got a bona fide user. This bona fide user may not use the spectrum for always. You will be not using it. Today, I am not using my mobile phone. The spectrum, what is meant for me, is really available for anybody to use it. So it is a responsibility of the cognitive radio system to recognize the slot or the empty slot available and try to find out if the empty slot can be provided to a user who wants to use it, but he is not a bona fide user. So he will temporarily take it, and after finishing that, he can go. If the original bona fide user comes and wants to use the spectrum, this non-bona fide user will be automatically removed by the system, and then bona fide user will be given the spectrum. See, what a great thing. Our spectrum utilization efficiency is working in a big way. And spectrum usage detection is actually can be done by spectrum analyzer, and software-defined radio can be made as a spectrum analyzer anytime. Okay, and it's a beautiful. Communication is full of such challenges, full of such solutions, full of such opportunities. Okay, so 4G. Now I'll go to the 4G and 5G. So these are all the various things. 0G, I have now put it actually represent the first generation. No G. What is this G? See, ultimately it is cellular communication. Okay, cellular communication, mobile communication. Cellular communication works on what we call actually circuit switching technique. Okay. Now you have what is known as the TCP/IP internet working on store and forward. What we call actually store and forward packet switching datagram or virtual circuit. It's usually packet switching datagram. Okay, this is what it is. This is very fast when you're talking about datagram, and so circuit switching has got its own overheads. Okay, now there is a G started by taking that particular circuit switching based board. On that, I am implementing the what is known as actually the 1G, 2G, 3G, 4G, etc. That means I am bringing together, we call actually convergence of circuit switching and packet switching, store and forward, datagram together. Thus, we get the speed. And also you will see, okay? And that is what it is. 1G is basically GSM system, digital GSM, group first person. So 2G, 2.5G, 3G, 4G, all those things. 4G is still a research lab. This is written actually some time back, okay? Where now people are, particularly our Indian government is saying we are already in 5G, okay? Time only will tell whether they are in 5G or not. I'm not going to contradict them. 4G features, fourth generation, in addition to the services of 3G, some additional features such as multimedia newspapers, also watch TV programs. Today we are using only 4G. We are not using 5G at all. Okay. So then 5G came. 5G.
Sir.
Yes, sir.
Last 5 minutes, sir.
You give me for 10 minutes. I'll finish it.
Okay, sir. Okay, sir. No problem.
So this is actually the candidate for 5G cellular. This is actually what I wanted to show you. 100 kilobits is actually 2G. 384 to 2 megabits is actually 3G. 150 to 450 megabits is actually 4G. Long-term evolution, A. 10 Gbps is 5G. That is one aspect of it. Second, the latency is 500 to 1000 milliseconds. That is as good as 1 second. Okay. This is 0.2 second. This is 0.1 second. Look at it, 0.001 second. That is 1 millisecond. In 5G, my latency is very low. So Internet of Things is going to use this 5G mainly because I want latency should be reduced, and latency is from the latency. You go look at the dictionary for definition. I will tell you my understanding. Latency is from the time the invitation comes till the time the target is answering is called latency, and that is what it is. So this is another way of looking at it. So learn by doing, excel through experimentation, lead by example. This is what my statement. Acquire skill, get employed, update skills, and stay employed. If you want to continue in the same teaching profession, you cannot still teaching about the analog modulation, analog communication system. You should move to 5G, and that is what will make sure you stay employed. Okay. And anybody, any college, any institution which wants certain things to be done from fundamental, please don't put me on to a syllabus-based teaching. I will never be able to teach. No, students will be only unhappy with me. Okay, I'm not interested. But somebody wants to learn the technology in the right manner, call Jairam. That's all. Okay. Thank you so much. And with that, actually, and if there is any question, I have 2 minutes. I'm sure you can wait for 2 more minutes and take the questions. I'll take the questions, and we can move. We can do a lot of things in that particular thing. Yeah, that's actually the one. With that, I close. Thank you so much for the patience as usual, and looking forward to questions if you have any, or if I am a good teacher, I would have explained everything properly. I think I can be proud about it, but still, you can send me the question on my mail ID. It's always available to you. Thank you so much. Nice of you. Thank you so much, Dr. Rohit and his team. Thank you so much for all the support I got. Thank you. Yeah, go ahead. Question. Question. Most of the people lunch, they have gone to lunch or still there. Rohit sir, everybody is there or still lunch is hello? 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 Harish?
Hello,
Harish?
sir. Hello.
Ah,
It's audible, sir?
I am audible.
Yes, yes, sir. Can we conclude, sir?
Oh yes, conclude.
Yes. Yeah. Any participants? Any doubt? Any doubts? You can ask it, sir. Okay, sir. Okay, sir. Very good presentation, sir. Thank you for your active participation. This is Sttp, sir.
Thank you.
Thank you, sir.
Thank you so much. Have a good afternoon. Enjoy the lunch. Forget about communication and modulation. Enjoy the lunch.